Okay, we'll be doing a word problem, okay, with a specific example that involves triangles and small angle approximation. So in the previous lesson, we talked about the steps, and here we're going to apply those 3 steps in solving this question, okay? So let's take a look at the question first. Now we have this diagram, okay, there's a triangle PQR, and then the angle P over here is theta, and the angle Q over here is theta plus pi over 4. Okay, no other information are available with regards to the length, okay, in this question. Now, given that the angle theta, okay, is sufficiently small, show that the ratio of QR over PR, okay, so QR over PR is approximately equals to A plus B theta, or rather A theta plus B theta squared, okay, where the constants A and B are to be determined in exact form. So remember that in step 1, we need to use, one of those either sine rule, okay, sine rule, cosine rule, or if we have a right angle triangle, then we will be thinking about the trigonometric ratios, okay? So we can use those to form an equation, right? So that would include the angle inside there, as well as some trigonometry functions. So in this case, we have the QR over PR, which is this, okay? So there's 2 sides involved and 2 angles that we know. So with 2 sides and 2 angles, it points to sine rule because that formula has 2 angles as well as 2 sides, all right? Now, we're going to go ahead and do that. So for reference, I'm going to also mark this as step number 1. Obviously, don't put this down in your solution during exams, okay? Now, with that, for sine rule, okay? So for those who need to recall how sine rules look like, it's sine A over A equals to sine B over B, okay? So in this case, we are going to use sine rule, right? So let's form the equation. We have, we can start off with this guy. So we have sine, which is the A angle, so to speak, okay, but this is P, right? So that will be over A, which is the opposite side, that happens to be QR, okay? And then after that, we're going to use this angle over here, which is sine theta plus pi over 4, sine theta plus pi over 4, and then over the the side on the opposite side, which is PR in this case, PR, okay? And they want us to form this ratio, right? So it's QR over PR. In that case, I'm going to multiply this over to the other side and take this, the numerator on the right hand side, and divide it over. So we have QR over PR, okay? Then when you move this over here, you move this over here, will be sine theta over sine theta plus pi over 4. Okay, so step 1 is pretty much done because we have now formulated a formula using one of these, okay? And this is what we have, right? And next up, what we need to do is that we will, okay, use small angle approximation to work on this, okay? And there is something important, okay, that you need to take note of, and that is this guy. Remember in the previous lesson, we also talked about when you have an angle x that is sufficiently small, but if you have it added to a constant, okay, then x plus a is not considered small, right? What we need to do, okay, in the previous lesson we talked about this, we are going to use compound angles to expand this, all right? So in order to do that, okay, let's just move step 2 further down, okay? Before we can apply the small angle approximation formulas, okay, we need to expand this, okay? So let's just take it further and go ahead and expand this. Now, at the same time, I think I'm going to put the QR and PR on the left side. So we got QR over PR is equal to sine theta over, okay, let's expand this using the compound angles. And if you don't remember this, those formulas are still available in your formula sheet, okay, the MF26, so you can refer to them. So sine A plus B is sine A, which is sine theta, cos B, which is pi over 4, and then plus, okay, then it's the other way around, cos A, which is sine theta, plus sine B, okay, so pi over 4, okay? And we can evaluate this, all right? What we'll have is this, okay? So we got sine theta, that remains no change, and then over, we can work out what cosine pi over 4 is. We can simply press this to our calculator. So cosine pi over 4. Oops. Excuse me. Okay, that gives us 0.707, but we need the values to be exact, right? So in that case, I'm going to square the answer and I get half. So I know that this is 1 over square root 2, okay? So we have 1 over square root 2 sine theta, and then plus, we can do likewise for the sine, okay? And it's going to give us the same answer as well. But let's just double check that, okay? Yep, so 1 over square root 2 cosine theta. Okay, we can simplify this a little bit by pulling out the 1 over square root 2, because this is a common factor for both of these terms. When we pull it out, then we have 1 divided by 1 over square root 2, which essentially gives us square root 2 sine theta over sine theta plus cosine theta. Okay, so I'm going to draw a line here. We're going to move forward to the next column on the right, okay, since I've run out of space to write further down. Okay, so this is step 1. Then in step 2, right? Okay, step 2. I'm going to erase this to free up some space. Okay. In step 2, what we're going to do is this. We are going to take small angle approximation, as we have learned for sine theta, all right? Okay, so we're going to do a curly. So there's a continuation from here. So the next line, which I write over here, will be a curly equal sign, due to the fact that we are going to take small angle approximation. So if theta is sufficiently small, then it will be approximately equal to square root 2x, okay? Or rather theta in this case, okay, square root 2 theta. And then over for sine theta, again, we can approximate that to theta. And then for cosine theta, it is 1 minus theta squared over 2 factorial. Again, I'm just going to leave it as 2. Okay. So in fact, if we want, we can rearrange this to look like this. Okay. We got square root 2 theta, and then after that we can rearrange this and move this to the numerator. So we can start with the 1, and then plus theta, and minus theta squared over 2. Okay, then close bracket to the power minus 1. Okay, so we switch back to equal sign, because this expression is exactly equal to this, okay? But this expression is approximately equal to this, okay? They are not exactly the same, okay? So we are ready to move on to step number 3, all right? And in step 3, we mentioned that we will go ahead and expand this using the Maclaurin expansion, okay? So we can refer to our formula sheet, the MF26 for it, and this one corresponds to this, okay? So let's just write it down in green over here for reference, and that will be 1 plus x to the power n is equals to 1 plus nx, okay, plus n times n minus 1 over 2 factorial x squared plus dot dot dot, all right? Now, the question wants us to approximate this, okay, up to theta square. And you notice that there is a theta on the outside over here. So later on, when we were to expand this, all we need to is to get to up to theta, because when we multiply the theta inside, we will get theta square, okay? So in fact, all we need to do is to expand this, okay, up to the second term over here. With n being minus 1, and then our x, okay, being this theta minus theta over square over 2, okay? So let's go ahead and continue with this. We have square root 2 theta, all right? And then after that, we're going to expand this using the formula over here, okay? That's step 3, right? So 1 plus, now we've got an n, which is minus 1, okay? So it's minus 1 over here. And then we've got an x, which is theta minus theta squared over 2, okay? And then we can do a plus dot 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 over here, right? Because we don't need the rest, we just need the theta squared. The next term, okay, if you were to think about it, the next term, which is this one over here, you would have the x, which is right here, right? So the lowest power when after you have expanded is theta squared. Okay, so the theta square over here, when multiplied to the theta outside the bracket, is going to give us theta cubed. Okay, so in this case, I'm not going to do the extra work or additional work because it's not required for this question, right? Because it's all the way to theta square, which will save us some time, especially during exam. Now, let's move on. We are going to simplify this. So we have 1 minus theta. Okay, and then the one over here is the plus theta square, right? We don't really need it as well, because when you have the theta square over here, you get theta times theta square. Again, we have theta cubed, which is not required. So I'm just going to put plus dot 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 like this. And then after that, we can expand this, which will give us square root 2 theta. Then this times this is going to give us minus square root 2 theta square plus dot dot dot. So since the thetas, the higher powers of thetas are actually sufficiently small, we can go ahead and ignore them, right? So you could just end off this by writing this is then approximately to be square root 2 theta minus square root 2 theta square. Okay? Alright? So they want us to figure out what is the a and b, so we're going to compare the coefficients. So therefore a must be square root 2, b must be minus square root 2. So we're going to go ahead and write that. Therefore a is equals to square root 2, and then b will be equals to minus square root 2. And there you go.